What's up, care peeps? Let's keep working with the pHs of strong acids and bases. This time, though, we're going to go in reverse. It says a sodium hydroxide solution is found to have a pH of 10.50. So we already know the pH. Determine the following. Calculate the hydronium ion concentration and calculate the hydroxide ion concentration. So once again, I'm going to turn to my formula chart and recognize that the formula for pH is equal to the negative log of the hydronium ion concentration. Not something you have to memorize, just make sure you can find it on your formula chart. I know the value of the pH is 10.50, and I'm looking for hydronium ion concentration. Now, here comes some math that, depending on your algebra skills, may or may not be pretty easy. I'm trying to solve for x, so the first thing I'm going to do is divide each side by -1. So I get negative 10.50 equals log of x. How do I get rid of that log? We're going to go exponential.
My music's so loud, I'm swinging.
It's going to go 10 to the negative 10.50 equals x. How do I do that on my calculator? It's hidden right beneath the log button. So second log negative 10.50 is x equals 3.2 times 10 to the negative 11 molar. That is my hydronium ion concentration. Boom. Next, I need the hydroxide ion concentration. And there's a couple different ways you can do this. You can subtract the pH from 14 to get the pOH, and then just do the same thing we've done here. Or you can recognize this other very important relationship that exists between hydronium and hydroxide ion concentrations. Also given to you on your formula chart, Kw is equal to hydronium ion concentration times hydroxide ion concentration. We know at 25 degrees Celsius, the value for Kw is 1.0 times 10 to the minus 14. And we just determined our hydronium ion concentration to be 3.2 times 10 to the minus 11. Now, some pretty easy algebra here to solve for x. 1.0 second e negative 14 close parentheses divided by 3.2 second e negative 11 close parentheses. X equals 3.1 times 10 to the minus 4 molar. And that is our hydroxide ion concentration. Boom. Now, always a good idea to stop and think about whether or not your answers make sense. Does it make sense if I have a sodium hydroxide solution, a solution in the basic range, to have a higher concentration of hydroxide, 10 to the minus 4, than hydronium, 10 to the minus 11? You betcha, we should have a greater concentration of hydroxide ion than hydronium ion in a basic solution, indicated by that basic pH. Oh, math. Bringing it all together.
They see me rolling, they hating.
We are done.